Hello ladies and gentlemen, welcome to this short video on descriptive biostatistics and more specifically the presentation of data by K. Hove. The objectives of this presentation is to explain the purpose of graphs, plots, tables and mathematical presentations, describe the methods of presenting data, explain the general rules for graphs and tables. Now, this is just a recap of biostatistics in general. We said biostatistics is divided into two branches, namely the inferential biostatistics as well as the descriptive biostatistics. We said the inferential biostatistics, basically we are using sample data to explain the population. You see, when we are doing research, we are not mainly interested in the sample results. So, but because of the constraints that we discussed the last time, where we said we may have financial constraints, time constraints, and so forth, we just focus on a sample that is a small subset of the population. Now, when we get the results of the small subset of the population called the sample, we want to infer, we want to extend, to generalize those results to explain the entire population. And we also said now we have another branch called descriptive biostatistics, which involves the use of measures. These measures are subdivided into central tendency as well as variability or dispersion measures, as well as graphical techniques in explaining the data. You see, data in its raw form does not make a lot of meaning. We need to refine it. We need to extract the information which is contained in the data. So in order for us to do that, we basically use the measures. It's either we calculate from the data the mean, mode, median, quarters and percentiles, or we can compute or calculate variability measures called the range, interquartile range, the coefficient of variation, the standard deviation, as well as the variance. But in most cases, you would realize that we don't use these in isolation. So in a research project or whatever, we normally use a combination of measures of central tendency, variability, as well as graphical techniques. So for the purpose of this particular video, we are going to focus on graphical techniques. And my understanding is that we have covered all the measures. That is the central tendency measures for both grouped and ungrouped. We have covered the variability of dispersion measures for both grouped and ungrouped. Now, why do we need graphs or plots or tables and mathematical presentation? If you get a report, for example, from the Namibian Statistical Agency, the census report, the entire report is full of graphs, plots, tables, and mathematical presentation. If you go to the library, you get hold of any textbook, not necessarily statistical textbook, even economics, you will see graphs showing trends, financial projections, and so forth. Why do we need this? We need graphs simply because they help to summarize and organize results in a clear manner, in a manner that makes the reader appreciate what the data is showing. They also help to condense raw data into a more useful form. Just imagine the Namibian Statistical Agency, after collecting statistical data during a census, they just take the data and present to the cabinet. Surely cabinet will not make any sense out of it. So they need to make the data digestible by summarizing, condensing large volumes of data into more useful form, upon which then decisions can be made. For example, if we talk of data on the number of old people, those people who might need old people's homes, we need to categorize the data by region. How many people by region? By sex, that is male and females who are above a certain age limit. We condense into different tables, graphs, and plots that will help decision makers to understand the dynamics around the issue. So to visualize, present a collection of results for the purpose of interpretation. You see, when we collect data, we need to have a clear visual picture of what the data is showing. Also, we use the graphs to disseminate, to communicate our research output to an audience. If you go to a conference, for example, you will find one presenter after the other showing graphs, tables of their outcome, because it is what the audience always appreciate. The audience will always understand better if we show our data in the form of tables. It's easy to follow than just showing a lot of paragraphs. Now, what are the methods of presenting data? We can use tables, we can use graphical presentations. I want you to appreciate there are so many graphs. We are going to look at so many graphical presentations. The histograms, the stem and leaf, the box and whisker, the bar graphs, the line graphs, and the scatter plots. So all these are used to show or to represent different data. And what some graphs are suitable for a certain data, whereas others are suitable for a certain data. And so we as we introduce each of these graphical techniques, we are going to explain what information or what type of data is bestly described by this particular graphical type. So we can also use mathematical presentation, that is statistical output, usually presented within the text of a report or publication. Now, what are the general rules for graphs and tables? Graphs and tables should be fully self-explanatory. You see, when you present a graph or a table in your research report and you find yourself having to write 2 pages or a full page explaining your particular graph, it means that graph is not self-explanatory. A reader must be able to look at the graph and make meaning out of what the graph is showing. They must be simple and easy to understand. Graphs and tables should be clearly labeled, including the units of measurements. I normally say when you take a graph out of the main text, or you throw a graph or a table, someone picks it up, the person must be able to interpret what the graph is showing without necessarily having to look at the source document. In graphs, minimize intersecting lines. Avoid graphs with more than 4 intersecting lines, because it will make it very difficult for a reader to interpret and appreciate what that graph is showing. Always include a title. For a table, the title must be above, and for a figure, the title must be below. But you need also to check the requirement, the requirement of the journal. If you are writing a scientific article, for example, to a journal, you need to check what are the requirements in terms of putting a title. Some journals might actually say you can put a title below a table, and vice versa. But the convention is that a title for a table is always above a table, and a title for a figure is always below. And you must also include the source of the data that is being displayed. If it is a table, show us this source is from your own survey, or source is from a publication by a certain organization. That is very, very important. You don't just take a table or a graph and put in your report or in your research project without acknowledging that. That will be tantamount to plagiarism. Have a key when necessary. Now, what are the general graphs for? What are the graphs for quantitative data? Pie charts and bar charts, line graphs, dot plots, stem and leaf graphs, box and whisker plots, histograms, the cumulative frequency curves, as well as a frequency polygon. So, thank you very much. In our next segment, we are going to look at each of these graphs in more detail, where we are going to focus now on how do we produce a pie chart, a bar chart. I know most of these graphs are general, not new to you, but some of them might actually require us to emphasize how to create them and so forth. So in this particular video, we have covered the final segment of descriptive biostatistics, more specifically the use of graphs, why do we need the graphs, and so forth. Thank you very much. Meet you in our next video. Enjoy.